Hello, everyone. We'll just give it a minute to let people continue joining, then we'll get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar on developing effective standard operating procedures. My name is Owen Volk from the Syracuse University Environmental Finance Center. Before we begin, we are going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it in the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information you may need. You can also download the slides and any other documents in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now, for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application, falling short on project funding, not sure where to start? EFCN is here to help. Submit a request through the link in the chat to receive tailored support based on your project needs. And on that note, we can get started. I would like to introduce our presenter for today, Gregory Pearson, Water and Wastewater Trainer at the Great Lakes Environmental Infrastructure Center. Welcome, Greg. I will go ahead and hand it over to you.
Thank you, Owen, and welcome everyone. Is the presentation up correctly on your end, Owen?
It looks good on my end.
Wonderful. All right, today we are going to be going through developing effective standard operating procedures, SOPs. It's going to be kind of a fast-paced training today. And I want to start by talking about the big idea of today's training is that SOPs are official documents that we use for critical tasks in a utility. And they're tasks that need to be performed in the same way for some reason. And those reasons could be to ensure safety, to ensure public and environmental health, compliance with regulations, or maybe to adhere to some certain type of standard. Um, we're going to be covering basically three main points in today's training. First, we're going to briefly talk about how to analyze when an SOP is actually necessary. You don't need an SOP for every task in a water and wastewater system. It's only for those critical tasks that need to be performed the same way each time. The main bulk of our training today is we're going to be walking through the 9 components of an SOP document. And we're going to be using an actual example from a utility that is called emergency repair of water main breaks. So we're going to be looking at the conceptual nature of the SOP as a 9-component document, but also looking in the context of an actual example. And lastly, throughout the training, we're going to be talking about tips for creating and testing SOPs. You have some resources in the handouts tab. One is you have 2 sample SOPs, actual SOPs that were developed, and we've redacted the names and identifying information from those SOPs. The second is an editable SOP template that you can use to develop your own SOPs. And lastly, there is some references. Did we lose the screen, Owen, or are we okay still?
Still able to see your slides.
Okay, good. And lastly, there's some reference links that are actually in your the PDF of the presentation. I'm going to go off camera for a little bit just to maximize the view of the slides for you on your end as we get going. So let's jump in here. And first of all, let's just briefly talk about what a standard operating procedure document is. First of all, it's an official document, and it's going to include step-by-step instructions for completing some type of critical task. And we want to be able to do that task in essentially the same way each time. And it may not be in a robotic way where every single action is exactly the same, but it follows a standardized sequence and standardized consideration, for example, safety considerations and responsibility assignments and so forth. It's always going to be referenced to some sort of standard. It might be an industry standard or a safety standard or some kind of best practice. And it's going to be a very comprehensive standalone document. You're not going to need necessarily to refer to other documents when you have a well-written SOP, because it's going to include all the necessary safety considerations. It's going to list the tools that you need. It's also going to include things like decision points. As you're going through the sequence of steps, there may be decision points where you need to go to, to method A or method B. And this document provides the answers to the basic 5 question types: the who, what, when, where, how. First of all, the what. In this case, in the example we're looking at today, is emergency water main break repair. And when is when a main break occurs. And where, in this case, it's in the context of a water distribution system. Now, the where could be well 1 or east treatment plant, but in this case, the where is anywhere in the distribution system. The who, in the example we're looking at today, includes 3 different employee groups. You have the distribution foreman, the distribution operators, and laboratory technicians that are all involved in this particular task. If you're developing an SOP for a different task, obviously all these questions would be different answers. And finally, the how tells what and how each of these employee groups is going to function during the SOP task. First of all, the distribution foreman in the example that we're looking at today is going to evaluate the site conditions for safety and the type of water main break, and is responsible for ensuring that there's resources and tools available to complete the task safely and effectively. The distribution operators are the ones that are going to actually excavate, repair, and disinfect the main, and they're going to collect bacteria samples. And then finally, the laboratory technicians are the ones that are going to run the coliform test and report back to the distribution foreman. And of course, once the main has been repaired and it's been flushed and disinfected, and the coliform results have been run, and there is a negative, there's no coliform in the system, then they're able to actually put the main back online. There is some consideration about when you actually need an SOP for a task. I mentioned before, you don't want to have an SOP necessarily for every single task. There's some reasons for that. It would become administratively difficult, but it would also be difficult for the operators, because we don't want our operators to be, our operations staff is not robots. They're our eyes and ears, and their knowledge and insights are essential. But in some cases, for very critical tasks, we need it to be done at least in the same type of sequence and considering the same type of factors. So some of the things that you can think about is, what are the consequences of failing to do it correctly, failing to do this particular task correctly? And that would let you know if an SOP is needed. So you can consider these 5 things. Would doing the task incorrectly result in some kind of public or environmental health problem? Would it result in a regulatory compliance problem, a safety hazard to operators or the public? Would it result in an outage or breakdown? And finally, would it result in some type of difficulty, as in like a high cost or difficult repair or difficulty to recover? At this point, that was kind of our introduction. We're going to go ahead and go to poll 1, and we're going to try our hand at analyzing if an SOP is needed.
Okay, so this poll should be going out now. We'll give it about a minute, and then we will get back with the results. And the 10 seconds. All right. So results are in. To the question of which of the following tasks do you think represents the greatest need for an SOP? 29% said installing a new water service. 5% said collecting accurate water meter readings. Another 5% said recording flow and pressure data during daily rounds. And then 61% said adjusting chemical dosages at surface water treatment plant.
Great.
Plant.
Thank you, Owen, and thank you everyone for participating. And I agree with the large majority of you that made those selections. Now we were looking for what's the greatest need among these, and with those 61%, I agree that's probably the greatest need, because adjusting the chemical dose at a surface water plant. Now, the effluent of a surface water plant needs to be within or below a certain turbidity limit. And when we have our coagulant adjusted correctly, we can meet that 0.3 NTU or less limit, so that we can ensure that there is no pathogens in the drinking water, and we can meet that compliance target. So there's compliance and public health involved there. Also, if our dose was too high, it's possible we could have toxic chemicals in the water. And also, when operators are handling the chemicals during the jar test, some of these chemicals are actually corrosive and hazardous. So there's a need to have certain types of personal protective equipment on. So there's multiple reasons why you would want to have an SOP, probably for adjusting chemical dosages. Now, installing a new water service is also important. I don't think it represents the greatest need here, but it's something you'd want potentially to do the same way each time, although there may be lots of variables, different types of mains in the ground, from asbestos to cement to cast iron to ductile irons. There might be a lot of variety, and probably the main thing is to make that connection to a certain standard. Operators may have some flexibility in the way they approach that. Collecting the water accurate water meter readings is probably not critical to health, safety, or compliance, and the method to record flow and pressure data is probably not as important as the pressure itself. But also, we recognize that pressure is a critical element in water distribution systems. I'm going to share with you some common problems that common and uncommon problems that have happened in water and wastewater too. And the first one is an installer skipping the step to confirm the direction of shaft rotation when they're connecting a turbine pump. The step gets skipped and the pump is turned on rotating backwards, and severe damage is done to this very expensive pump, damaging the impellers, the casing, the bearings, and the shaft. And so that would be an example of something that would, if you did it wrong, would result in a lot of repair, high repair cost, a lot of hassle come out. You'd have to pull this beautiful pump again. There'd be an extended outage probably. Second one involves a safety issue. We have an operator is going to install a 480 volt pump starter and forgot the lockout tagout kit back at the utility shop, and decides to just turn off the switch at the panel and begin working. And while that operator is working, another operator comes along to the panel and sees that the switch is off and flips it back on. And so that could be an incident where you have someone getting shocked, maybe even killed. So you have a safety incident and you have a problem with OSHA compliance. I have a couple little notes at the bottom of this slide. And incidents like these really can't be called a freak accident, because a freak accident is when you do everything you're supposed to do and an accident still happens. Maybe that happens 1 in 10,000 times. But these preventable type incidents actually happen a little bit too often. And part of that is the second bullet point on my notes at the bottom, is that violating safety principles can be kind of deceptive, because if we get away with doing an unsafe act, our mind kind of learns that, like going into a confined space and nothing happens to us, our mind is telling us, hey, that's a safe place to go in. But in fact, with confined spaces, 1 in 4 confined spaces is said to have an atmosphere that would result in a 1 breath death. So you might go into 3 confined spaces, have no problem, but the 4th one might be the one that does some harm to us. The third one here is a compliance issue, and this was an actual event that occurred where an employee overrode a waste treatment alarm, and it resulted in 10,000 gallons of hexavalent chromium being discharged in the Huron River in Michigan. And so this was obviously a compliance problem, and they did fire the employee, but we don't know enough about the story to say that it was all the employee's fault. Maybe the employee was told, hey, if this alarm goes off, just override it. We don't know the details, but obviously that would be a indication we should investigate why that alarm is going off. So that was an example of a task that, if done wrong, could result in environmental and public health problems. That hexavalent chromium is the same chemical that was in the Aaron Brockovich story, by the way. There are some problems with SOPs. On one hand, we're saying make sure that you have reason to have a SOP. It's a lot of work to develop SOP, and there's strict procedures that have to be followed. And so that's one of the reasons why you don't want to develop an SOP just for every task. You don't want too many. Also, number one here, SOPs which are no longer relevant. And why wouldn't they be relevant? Well, they might have been developed, but since then the process or the equipment has been changed, so they haven't been updated. Impractical or poorly written SOPs make it more of a hassle to follow the SOP, or it could even result in mistakes. And having too many SOPs for too many tasks, that can really lead to kind of a culture where employees start disregarding even the well-written and critical SOPs. It also can kind of interfere with operator initiative. Operators are your eyes and ears, the decision makers out in the field, and you want them to be using their knowledge to the best of their ability. And there's another side to this coin, though, is when we have good SOPs which are not used, and that has to do with more of an internal factors. One of the first factors is employees may not have the knowledge to perform the task. They just don't know how, and that could be corrected with training. The second layer is they know how, but they don't have the tools or resources. So insufficient resources necessary for the task. That would indicate we have a budgeting problem at our utility. And then there might be a lack of clear direction and expectation. In this case, the employees may know how to do the task and have the tools, but they didn't know that they were supposed to perform the task. So that would be kind of a management and communication problem. We have a lack of communication. And finally, a lack of motivation. The employees have the tools, they have the resources, they know they're supposed to do it, but for some reason they either didn't want to do it or didn't think it was important to do it, to do it the way the SOP said. And that could indicate that we have some kind of cultural problem or perhaps a employee problem. And that brings us to the idea, our first point there was SOPs that are no longer relevant. So we want to make sure we maintain our SOPs. And I have a little scenario here for you. We have a new operator, and this operator goes out to a sodium hypochlorite feed system at a well, and the sodium, this operator needs to adjust the sodium hypochlorite feed system for disinfection, and thumbs through the SOP binder, but the only SOP on adjusting disinfection is some instructions for the old gas chlorinator that used to be at the site. So my question is, what could have been done to prevent this situation? Would it have been a procedure to periodically review and update the SOPs? A policy to develop SOPs for every time we have some kind of new equipment installation or change? Some kind of practice on onboarding staff about critical O&M procedures? Or would it be all of the above? And we're going to bring up a poll here, poll 2, and you can answer this question. We can discuss it.
Okay, so we'll give it about a minute. I know the question portion isn't there, but the question again was what could have prevented this? About 15 seconds. Okay, so poll results are in. It's pretty lopsided. About 6% said procedure to periodically review and update SOPs. 2% said a policy to create SOPs for new critical equipment installs, and 92% said all of the above.
Well, I have news for everyone. Everyone got it right, because all of the above means if you picked one of the above, you're correct. So obviously all of the above, right? What would a procedure to periodically review and update SOPs look like? Well, that could look like some type of annual review where you gather with the operators, maybe a consultant, and you review all the SOPs and ask, do we need to update? Do we need to revise? The second, a policy to develop SOPs for any new equipment installations or changes. So every time there's a new project in the capital improvement plan or some kind of a change, we have a checklist that says, hey, check out the SOP. That's a good idea too, isn't it? And then finally, some kind of practice when you onboard staff where they are trained on the SOPs. So those are all suggestions that you could potentially bring into your own utilities. So we want to make sure we have some procedures in place to review and update SOPs anytime there's any of these type of changes. And also it kind of helps us to connect this idea of how SOPs are kind of components. They're tied in to employee training and onboarding. Thanks for all your participation. You guys are great. Is everybody following along okay? Are you enjoying the training so far? Right now, we're going to launch in to kind of the meat of the training today. And we're going to talk about a suggested format for developing an SOP. There's a total of 9 components. And I'm going to go through all 9 components here as completely and quickly as I can. I'm going to try to strike a balance between the two so it doesn't become monotonous. And but also I want to let you know that the sample SOP that you have as one of your handouts, it's the full SOP, and we're going through, like I said, that SOP on emergency repair of water main breaks. And that's the example we're using. But the components, the 9 components, it's a template that you can use with any task that you need an SOP for. Now, among these 9 components, the first 2 are kind of administrative. You have the title page, and then you have a document control page. And then there's the remaining 7 components are really the contents of the SOP. They're directly related to the tasks that are in the instructions of the SOP. So, like I said, we're going to be looking at emergency repair of water mains as our example, but we're providing kind of a format for any SOP. And this is the 9, if I look at all the 9 components at once, this is what they would look like. You have the title page, where you have a standard naming procedure, then the document control page, that's page 2. Then you have the contents. You define any acronyms or terms. You cite the staff responsibilities in number 2. Number 3, you describe the scope and purpose of the SOP. In number 4, you talk about any safety issues associated with the particular task, and that's going to be different for each task. Then number 5, we actually get to the procedures, the step-by-step procedures, and we're listing all the required tools and equipment and resources that we need for the task. Then finally, there's going to be some data that needs to be collected associated with the task that you're assigning. And then finally, the references that your SOP is based on. And just again, to mention, you have some resources. We have a template with instructions, and you have a unique utility with unique needs. So you can take that, feel free to edit it in a way that meets the needs of your utility. And if you need help with developing SOPs, you can contact anyone. You can contact me or anyone throughout the EFCN to help you develop an SOP. We're going to start by looking at the title page. And the main idea of the title page here is to select a title that clearly identifies the task. And in the example we're going to show you, they have some other details, some other summary details on the title page, including the file number, the revision number, and the date. So you can see they titled it Emergency Repair of Water Mains SOP, and you can't mistake that, right? That's operational language. It's very clear. There's no question about what the SOP is about. Secondly, they have the number. Evidently, this is the 311th SOP this utility developed, and they have the date at the bottom, and then they have the revision number. And you notice that revision number 0.0, it means they haven't had any revisions for this particular SOP yet. Now that format of 0.0, the number before the decimal is for major revision. So 1.0 would be the first major revision, and let's say 1.1, that would mean you had also a minor revision. The number after the decimal is for minor revisions. That's one possible way that you can track revisions. Also notice they have a logo at the top, and so it kind of indicates this is an official document of the utility. So those are all good tips to develop your title page, something that's very clear. You notice they have a nice large font for the title. After the title page, we have the document control page, and we have a template for that. That's a place where you can track any revisions. And when you create an SOP or make a revision, you'll probably have somebody that approves that. It might be the distribution supervisor or utility manager. And you can also record when employees have received training on the SOP. Here's an example of what that might look like. Before you look at that, I want you to also notice at the top here, we have a header. So that header, you can select that in Word so that it only appears on page 2 and beyond, but that's the same as the title, Emergency Repair of Water Main. So any page that you're on in the SOP, you know what the SOP is about. So that would really be helpful if you're going to have your annual review of all of your SOPs. It would be very useful to have that running header throughout the document. Notice in the SOP version control, you can track the revisions under the description, why it was revised, and who approved it. And lastly, down here, you can have a place to review that staff was trained on this SOP. Now that's not just keeping staff accountable, that's also keeping management accountable, because if they send a bunch of staff out to do an SOP related task, they need to have provided the adequate training to that staff crew that's going to go out and do that task. The third component here is the first part of our actual contents, is the definitions. And here we're going to define any acronyms or terms that we're going to use throughout the SOP. So let's take a look at that. In this case, this is their full list for this particular example. They just have 5 acronyms here. AWWA and OSHA I'm familiar with. The one that looks a little bit unfamiliar with is this term EAM, and they've defined it for us, Enterprise Asset Management System. They have some kind of a database where they store all of their asset data. So you want to spell out any acronyms, and it's a good idea to define any unfamiliar terms as well. And the reason it's important to spell out acronyms is they can have more than one meaning. I picked a couple of very common water acronyms, for example, ERP. When I hear ERP, that tells me emergency response plan, but that, if you look it up on Google, that they won't give you emergency response plan, they will give you enterprise resource plan. The same thing with CCR. To my water operator brain, that says consumer confidence report, but that can also mean a real estate term, covenants, conditions, and restrictions. And it can also mean a business term, cash conversion rate. So it's a very good idea to spell those out, exactly what you mean in that SOP. Now, the second part of the contents, responsibilities, that's about assigning the responsibilities of all your personnel, of key personnel. We'll take a look what that looks like here. A couple of important things is that each employee group is assigned responsibilities, and you don't have crossover. You wouldn't want to assign the same task to more than one employee group, and you wouldn't want to leave any task unassigned. So this process of going through this actually helps you make sure that doesn't happen. You notice in this case, here we have the foreman, and just like that chart we had at the beginning of the presentation today, they're overseeing the repair, and they're documenting the repair in the EAM system. And now we know what EAM stands for, right? Because we had the definitions. We know that stands for Enterprise Asset Management System. The operators, they're the ones that actually make the repairs and collect the samples, and the laboratory techs, they analyze the BAC-T samples and report to the foreman. It's a good idea to use bulleted lists like this, and very succinct, clear operational language. It makes it very efficient, and you see it can be done very simply. You see just the bulleted list of tasks that each employee group is responsible for. So succinct language, operational terms. And the next component is the scope or purpose of the SOP. Now, when you notice that this falls on the like the 5th page of the SOP, but this may actually be where you would start in developing an SOP, because it talks about what the SOP is intended to do. What are we trying to accomplish with this task? And here's an example. Now, most of these sections I'm showing you, I can't fit the whole thing on this little slide in a PowerPoint slideshow. That's why you have the example SOP as a handout. This one, however, I am showing you the whole thing. This is the entire section on scope and purpose. So just one simple paragraph. And in this case, what they're saying to us is that this SOP outlines main break repair procedures. And they're talking about how it's done according to a certain standard. In this case, an AWWA standard, standard C651. And it's also implied that they're doing this because it's important for microbial control and protection of public health. So some tips for creating this section. And this section is important because you can really start with this and write the rest of your SOP, because you know the focus of what you're trying to accomplish. So the first step, the first consideration, I should say, explain what the SOP accomplishes in just one short paragraph. And you can state what the task is and why it's important, what you're trying to accomplish. So some components of why it might be important is you might be doing it because there's a safety consideration, a public health consideration, to make sure you comply with regulations, or like in this case, how you're going to adhere to a certain standard. Now we're moving on. I hope you're following along okay. I hope it's not drudgery to go through this the way we're doing it. But the next step is health and safety. In this section, you want to list all of the possible hazards, any factors such as worksite setup, any training that's required, and personal protective equipment that might be needed for the task. So let's take a look here, and this is one that I couldn't fit, obviously, everything for health and safety in one slide, so I've abbreviated it for you. So first of all, the first section of this health and safety component would be to identify the types of hazards that would be expected with this task. In this case, we're talking about emergency main brake repair. Well, emergency main brakes could happen at 3 in the morning. They could happen on a very busy highway, but they could also happen on a kind of a relatively unused little section of road too. So we have some variability here. There could be traffic hazards, there could be heavy construction hazards, trenching and even confined space hazards, and there could even be situations with hazardous chemicals as we're disinfecting the main. There's lots of other types of hazards that could be present depending on the tasks that you're doing. Could be stored energy hazards, such as electricity or high pressure and confined space hazards and so forth, temperature hazards. But you would list all the hazards for the type of tasks that you're designing the SOP for. Then you would talk about worksite design. How is your worksite going to be set up to mitigate the safety hazards? And in the case of this particular SOP that we're using as an example, you're going to need things potentially like signage and flashers and cones, possibly lighting for the traffic safety setup. And for the excavation, you're going to need things such as shoring or sloping to prevent cave-in. Then the third component of this section would be, is there any special training requirements, any special requirements for permits, for example? And obviously something like confined space, you might have a permit entry confined space, or you might need to have been trained on how to use an SCBA, things of that nature. And then lastly, you would want to talk about the types of personal protective equipment or PPE that's needed for the task. And then we get to the procedures. This is the component that we usually think of as the SOP. So in this, we're going to talk about the chronological step-by-step procedures, but we're also going to be listing all the required tools and resources needed in this section. And this is also abbreviated. Now, the entire length of the example SOP for this particular topic is about 10 pages, I think. So it's not like we're writing a book, but they're a little bit too long, some of these sections, to fit on one slide. But I'm going to give you an example of how some of the sections start and how they're chronologically oriented. What we're doing here is providing a very detailed list of any equipment, tools, and parts, even system maps, things you might not think about as tools, but system maps, maybe you need metal detectors and so forth, valve wrenches, of course. And we're doing this according to a certain standard. And then you see number one, the first step, you arrive at the site and you evaluate the site for safety. And then the next thing, you evaluate, do we need to isolate the pipe section by closing some valves? The third, excavating the break. We're going to actually dig down to the main to get to the break, and we're going to have to install sloping and shoring or some kind of safety measures. And finally, repairing the break, and then it goes on. So you see how these are chronological, but also notice those words that I highlighted with blue font. Those are action verbs. So you want to list and describe as completely but briefly as possible each procedure in a step-by-step sequential fashion, but also use very clear active language. You notice evaluate, set up, excavate, repair. Those are operational terms, very direct, and it's very easy for someone that's in the heat of the moment going to repair a main break, say at night with busy traffic all around. It's very clear to understand what needs to be done first and second and third and fourth. Also, in this procedures section, there may be the need for decision points. In this case, and according to the standard that's being used in this example, there is some decision points. So you notice that verbiage there on the right-hand side of your screen. If needed, disinfect the pipe in accordance with the described method outlined in C651. Okay, so what does that mean? Well, it means that there's different types of main breaks and there's different types of pressure conditions. So for example, if you go up to a main and it has a small hairline crack and it's spraying out water, but it hasn't lost pressure, that's a very different situation than a main that is completely busted and all the pressure's been lost. It's very different as far as the disinfection procedures and the flushing procedures that you're going to use, and whether you're going to isolate or not. For example, a thin hairline crack that with pressure could be repaired probably in a very different way. You might not have to take the whole section of main out. Maybe you can use a full circle clamp and get that taken care of, and plan a replacement later. And you wouldn't necessarily have to disinfect that type of repair in the same way that you would for a main break that's lost all pressure. Now the next section here is data recording. Well, this is an assignment within the SOP that certain data needs to be collected as part of the procedure. And we'll look at an example for the sample SOP. You notice the first sentence here: following a main break, enter all necessary information into the EAM system. And once again, we know that is the Enterprise Asset Management System because we've defined the acronym. And they've listed, in this case, some types of data that needs to be collected. What's the date and time? What seems to be the cause? What type of break was it? What type of pipe was it? And so on. And it's good to collect data, especially with underground assets, because how often do you go down and look at your water mains that are under the ground? Well, the only time you really get a chance to look at them is when you install a service or you make a repair. So that's essential data that you can use for asset management, condition assessment, and you can use it for future planning to plan maintenance and repair and replacement schedules. And you could even use the data to evaluate the SOP. I mean, you might record how long did this whole procedure take? Were there any problems with the SOP? And finally, the last part of the SOP is simply the references, the standards that we're basing the SOP on. And in this case, they're using two AWWA standards, C651-14 for disinfecting water mains, and C652-11 for disinfecting water storage facilities. So the standards that you use for your particular SOP might be different depending on what you're trying to accomplish. And they also have some reference materials. They have a scientific study here that was done to look at what are effective microbial control strategies for repairing main breaks. So you can list that in your reference section. And there's other types of standards that you might use, and this is not by no means a complete listing of all types of standards, but there may be ANSI standards, American National Standards Institute, Water Environment Federation standards. You may be using the 10 state standards for either water or wastewater. There's OSHA standards. There's even EPA standard methods for laboratory examination of water and wastewater, and that's just a short list of some of the types of standards, and I've included some of those in the reference slide near the end of this presentation. You can take a look at. Now that kind of completes our walk through the 9 components of an SOP, and let's take a little look at a scenario here. We have an SOP that we're going to develop for a jar testing procedure. We kind of had an example like this earlier where we picked out a name for a a jar testing procedure. Now we have this this procedure where we're going to determine the optimal coagulant dosage, though. So we have this optimized turbidity goal of the effluent that is 0.1 NTU. The compliance goal is 0.3, but we have this optimized goal of 0.1. And so what are some factors that we need to think about that's going to be included in the task? Well, there's going to be some decision points we know right off the bat, because we may be using different types of coagulants. Water quality can vary quite a bit in the raw water turbidity, pH, the temperature, and so forth. And we'd want to have some instruction about mixing speeds. We'd have some kind of a mixing speed that would simulate flash mixing for the coagulation component. And then we'd have a slower mixing speed to simulate flocculation. And then we'd have a settling time, probably maybe 30 minutes. And we'd have to have some kind of way to evaluate how close did we get to the optimal result. We'd have to measure the turbidity before and after, and look at the quality of the flock, how well did it settle, and so forth. And what types of things would we think about for the SOP? Well, we'd have some different elements we'd think about. One would be, what kind of standards will we reference? What level of skill is required? Is there any safety hazards associated with this? And what kind of tools and PPE are needed for the task? And finally, what should the title for this SOP be? And we'll bring up a poll, and you can tell us what title you think is best for this task.
Okay, the poll's been launched. Give it about a minute. Okay, about another 15 seconds. Okay. So results-wise, 6% said minimizing finished water turbidity would be a good title. 10% said determining coagulant dosage. 72% said jar testing procedure for coagulant dosage, and 12% said how to run a jar test.
Okay. Well, thank you for that. And I don't think there's any particular right answer. It has to be the answer that helps you and your staff know exactly what the task is. Now, among these, I picked C, jar testing procedure for coagulant dosage, because that tells me, in my way of thinking, more clearly what the particular task is. But I think probably any of these would be good if it helps you to know, and your staff to know, exactly what task you're trying to accomplish. Now we had talked about there's some other considerations for this SOP, and one is there a standard that we'd reference to develop this, and there is a manual M37 that AWWA puts out that's all about controlling coagulation and filtration processes, and you could certainly look in that manual to get information about jar testing. And also, if you go to OSHA.gov, you'll find information on chemical hazard and toxic substances standards, safety standards, and those are two examples of sources you might include in your reference section of your SOP. You can also test an SOP, and one of the best ways to test it is to have different people perform the task based just on the instructions. So you would hand them the instructions of the SOP, the instructions component, the step-by-step part in section 5 of the contents, and see if they can complete the task successfully. And another thing that you could do was have people perform the task in different settings. Taking repairing a main break, for example, would be different in the middle of a very busy city street than a quiet alley. It would be different if you have a massive beam break compared to a small leak. There's lots of variables, the depth of the main, the type of material of the main. So the thing you're looking for, is there any misunderstanding areas that need revision in the SOP? And if we look at different performance in different settings, it might tell us if we need to add decision points for different types of variables. There's a kind of a fun thing you could do among your staff if you want to help your staff get awareness of the level of precision needed to create SOPs. And one of the things is you could just assign, say you had 5 or 6 staff members and they each create some kind of a simple Lego block house or Lego block shape. And then they write down the instructions of the steps it took them to make that shape. When they all get done creating their shape, and they create the instructions, they create their little SOP, and then they trade that SOP with each other. And their partner, using just the instructions they've given them, should be able to create the exact same house or shape if they had very accurate instructions. So that's an exercise that you could try. We're starting to wind down to the end now, and I have a scenario for you. We have a scenario here that we're going to apply to our own utility, and we're going to pretend like we're part of this utility. Okay, we have a utility that has 2 operators and 1 manager, but one of these operators has only been working for 2 weeks, and they've been shadowing the senior operator. Now the manager took a vacation overseas. Manager's out of the office, and today the senior operator fell ill and called in sick. So the only person you have working is the new operator, and we have a power surge that knocks out power to half the town. In this half of the town, there's the main well and disinfection system. There's also a backup generator at this location, but being that this is the main well, they depend mostly on the water from this one well. And at the current rate of usage on this hot summer day, they predict that the storage tank is going to be empty within 2 hours. And then they're going to have problem providing water to people. They're going to have potentially low pressures, which can lead to public health problems. And there's also going to be some problems with fire flow. They're not going to have sufficient water for fire flow. So if this was your system and you needed to get this generator started and the well and disinfection system back up to speed, where would this new operator need to go to find the information to get this generator working and transferred and the well and disinfection system back online? Where would they go? And so we have some options here, and we're going to bring it up on poll 4 when they need to thumb through the O&M manual. The instructions are at the well. The operator already has a binder that contains SOPs and has been practicing them. Or would the operator have to try to contact the vacationing manager or sick operator? So this is something for you to think about. What would happen at your utility? Is there a place to find this information? And if it's something else, you can put it in the chat.
Okay, so the poll's been up and running. We'll give it another half minute.
I like the way you keep us honest, Owen.
Thank you, thank you. Okay, another 10 seconds. Okay, I think we're good to go. So results wise, 7% said thumb through the O and M manual and search through files. 13% said instructions have been placed on the wall or on the wall at the well. My apologies. 67% said operator has binder containing SOPs and has practiced them. And then 14% say the operator must contact the absent manager or operator.
Okay, that's good. And of course, the ideal thing is also that the operator has that binder, right, and has been practicing those SOPs. But it's a good thing to think about, right? Where would that operator need to go? So thank you for your participation, and for those of you especially that were brave enough to say that, that the operator would have to contact the vacationing manager or thumb through the O&M manual. I want to end with some tips for successful implementation of SOPs. It's a good idea to involve your staff in developing SOPs and to test them. You want to make them accessible, easily accessible, and provide training, especially during onboarding. And you want to budget time for employees to enter that data that's required to be collected in the SOP, and ensure the employees have the necessary training and equipment to carry out the task in the SOPs. And you want to create a process to review and update your SOPs at least annually, and whenever there's any kind of equipment or process changes. And as we're nearing the end here, I want to let you know that you can go to efcnetwork.org, and there's a variety of resources there, from funding guides. You can request technical assistance at no cost, register for more training events like this, and there's dozens of tools and resources, videos, blog articles. If you'd like to visit the Great Lakes Environmental Infrastructure Center, where I'm coming from, it's gleic.org. You can also, you're welcome to contact me directly at gpearson@mtu.edu. And don't forget to collect your handouts today, this example SOPs and the template. And you can contact me or anyone at the EFC network for help developing additional SOPs. This slide, as I promised, includes several resources and links to standards. And I want to thank you for participating today. You guys were really great. We didn't have a whole lot of interactivity, but I could see you were participating in the polls, and let you know that we're open for questions now. And if you would like to, I welcome you to share something you enjoyed learning about today in the chat.
Awesome. Thank you so much. If anyone has any questions, feel free to throw them in the chat. I know we're a little bit over on time. We can try to run through a couple. If you have to go, that's okay. You'll still be receiving certificate. Let me run back. I know one of the questions was there will be a video recording that is available in the follow-up email, which I will mention in our closing. It will be linked within there. Let me see if there's any questions. A lot of people very appreciative of your presentation. Believe you did a very good job. All right, here's a couple questions. How long should SOPs be? Does the length of the document affect the effectiveness?
Well, that's a good question. The examples I think that we've attached here, you'll see there, the longest one is 10 pages. So you're going for brevity. You might want to have someone to help you edit the SOP to make it as succinct and straightforward as possible. But I think using bullet points and targeted operational language will help you to keep it brief. It depends on the complexity of the task, of course. But you'll see this example for emergency repair of water main breaks. It's a fairly complex SOP, and it's only 10 pages. I think that gives you an idea.
Awesome. Let's see. Yeah, at this point, a lot of people sending in thanks for the excellent presentation. I'll give it a sec if anyone has any other last minute questions, and then we can wrap up.
I appreciate all of your willingness to be at this training, and it tells me that there's a lot of utilities out there that are interested in improving their operational oversight, and I'm really glad to see everyone here. I appreciate you taking the time to attend today. Thank you, Owen, for helping us with your moderation.
Yeah, of course. We have two other questions that we'll run, and then we can wrap up really quick. One person says, "Do you favor putting in actual pictures, like pictures, into an SOP?"
For some reason, I do. I haven't seen that uh, being done, but I would recommend you could have, if there's a decision tree, for example, that's easier to show graphically than it is to list verbally. I think that's a good idea. And the only problem with images, like repairing a main break, say you're going to show putting a full circle clamp on a pipe. The only danger of that would be is if you had radically different types of clamps and radically different types of pipe, it could, it might not look the same to the operator. They're looking at the image and they're looking at the actual thing. But as long as those could line up and where what they're seeing is going to be what they see in the field, I think it would be ideal.
Awesome. And we'll wrap up on this final question. This person says that they're a regulator and see all sorts of SOPs, some that are good, some that are bad, and they range from very formal to informal. In your opinion, what tends to be the most helpful for the end user?
Um, I like to see a direct operational language because we're not writing them to submit it to an essay contest or even to impress a regulator, even though we want the regulators to appreciate what we're doing. And we're not writing it with anything like engineering language or scientific language. It's got to be language that is meaningful to the operators that are going to be reading it and implementing it. So that's your target audience for writing it, operators. And not that we have to dumb it down for operators. I'm not saying that. I'm just saying that operators are out in the field under the pressure of the moment, and we need to provide clear operational terms. Isolate the main. Operators know what that means. And so we wouldn't want to use any obscure term for that. We want operational language.
Awesome. And I know I said that was going to be the last. We got one more that I think is pretty important to the topic. What is your take on the addition of QR codes into SOPs to direct personnel to maintenance videos or process videos?
I think that's great. I would love to work with a utility at some point who is willing to do that. And the way I envision it working, let's say you're at well one and you have a QR code on the wall that you could scan with your phone or pad, and it would bring up a video of how to actually mix a solution or to set a pump or repair common things that could happen at that well or other facility. It doesn't have to be a well. I think that would be ideal. I wouldn't want to depend on that solely because those kind of systems could have errors. I'd always want to have a backup written document. I think it's a great idea.
Fantastic. On that note, we can wrap up. Huge thank you to Greg for sharing his expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We would also ask that you complete the webinar evaluation following the webinar so that you can let us know your thoughts on today's session, as it helps us with future webinars on topics that are important to you. Plan for future webinars on topics that are important to you. Thank you again, and we hope to see you at future EFCN events.
Thank you, everyone.